working out a confidence interval for the population mean, where the population is known to be normally distributed, but the population standard deviation is unknown, and using a small random sample. Hence, the t distribution will be used, and not the normal distribution. A large hotel provides breakfast at any time between 6 a.m. and 10 a.m. The manager selected 9 guests, n equals 9, randomly, who were staying in the hotel, and recorded the number of minutes after 6 a.m. at which they arrived for breakfast. So for example, this guest here arrived 139 minutes after 6 a.m. and we're going to work out a 95% confidence interval for the mean number of minutes, so which is this, after 6 a.m. at which guests arrive for breakfast. So we don't know the population mean, we don't know the population standard deviation, it's not given. So what we're going to do is we're going to put this data into the calculator to work out the sample mean and the standard deviation, the sample standard deviation for this data. All 9 values are now in the calculator. So the sample mean, 112.67, and the standard deviation, option 4, because we're using a sample, 70.61. To calculate the confidence interval for the population mean, we're going to use the t distribution. One of the conditions for the t distribution is that the population must be normally distributed. And the population standard deviation must be unknown, and the sample size must be small. If these conditions are met, then the t distribution would be appropriate. We're using the t distribution and not the normal distribution because the t distribution takes care of the uncertainty in this value because it came from a small sample. In the probability tables, when working with the t distribution, we need to know this value here, the number of degrees of freedom, which is n-1. So we have 9 minus 1, 8 degrees of freedom. So for a 95% confidence interval, the cumulative probability to the left of this line is 97.5%. So we're going to use p is equal to 0.975 with 8 degrees of freedom. We go to the probability tables, 0.975, 8 degrees of freedom, so our t value is 2.306. So the lower confidence limit, using the minus, is 58.39. And the upper limit, 166.9. So just going over the conditions for the t distribution, the population must be normally distributed, population standard deviation must be unknown, and a small random sample is being used. And because the sample is small, we try to estimate this population standard deviation from the sample standard deviation, and there's a lot of uncertainty because the sample is too small. And the t distribution is taking care of that uncertainty.